Hello everybody and welcome. Today we're going to be talking about isolating variables and solving literal equations. So your goal after watching this video will be able to isolate a variable in a multivariable equation and to be able to write out and solve literal equations as well. So those are the two kind of focus points that we have for today, and like we always do, grounding it in a real life example. So below what you're going to see is, again, an example of something that you might find yourself in if you have a budget for spending and you have to buy multiple items. So the multiple items here, we have our shoes and food, and our budget is the $400. So the idea for this is that you don't know how many shoes you buy, you don't know how many meals you buy, so they're two different variables. That's our multivariable equation. And the honest answer to what you can buy is that it depends on how much of the other thing that you get. So for example, if we have like 100x for the shoes and 20y for our meals and our total budget is $400, so a fun weekend there for sure. If someone were to ask you like, okay, how much did you eat? Well, your answer would be, I don't know, until we get the y by itself, or until we get our food alone. So our goal for today is to take a situation like this, and just like we're doing here, to go through and solve and say, y, or how much I eat, is going to depend on the amount of shoes I buy and also on the total budget. So what we're going to notice here is that, so y, again, this is our food, x is the shoes. Shoes has a negative relationship with food because the more shoes that you buy, the less food you're going to be able to buy. So this equation to us should make some sense, but that's kind of the goal of what we're working towards today, is to take a multivariable equation to get one variable alone, and then to be able to answer a question based off of that. So for example, if someone were to say, okay, well, you buy 2 pairs of shoes, that's going to tell you how much food you can buy if you plug in the shoes for x. So that's our full drawn out example for today. And again, that's our goal, is taking a multivariable situation and just solving in terms of one variable. So getting like a y or an x alone on one side, and solving in that way. So our first definition for today, like we actually just did right there, is isolating a variable. And this is when we rearrange an algebraic equation. So a variable is on its own. It's a really fancy way of saying if you have something like, 5x minus 2y equals 47, we're just trying to get either x or y by itself. So for example, a question type might be like, solve for x. So in that situation, what we'd have to do is we'd be moving the y over. We'd get 5x equals 2y plus 47, and we'd be dividing everything by 5 to get an x equals. So it's isolated if it's just that variable by itself on that side. So that's our goal. So we've already done kind of 2 applied examples here, but we'll do one more so that way we can see some clear steps on how to go through and solve and what these questions might look like. So the first one is asking us to solve for a. So we're noticing that in this equation, our final answer will be a equals something. So time to move everything that's not an a away. We're going to see a equals j minus 2b. And that's the final answer. We don't care about solving for a number. We have to be very careful to keep like terms in order. And the only thing that we're looking for here is just an a equals. So for example, on this next equation, our goal is to get a t equals. So a little bit more challenging here. P and r. So I equals PRT. So to get t by itself, we have to divide, because it's p times r times t. Divide by everything that is not t. So I'll have I over p times r equals t. And we did it, we got t by itself. That's all that we're looking for. So carefully go through these remaining equations on this page here. And again, for this one, solve for h. For the next one, solve for y. And just make sure that it is alone on its side of the equation. All right, one more definition for today. We are looking finally at literal equations. And we actually just looked at a few of them. So this is an equation where variables represent known values. And known values are just things that we know. So for example, in like y equals mx plus b, we know slope, and we know that b represents our y-intercept. So that is a literal equation. If we plug in numbers for it, it's going to change it. But if it's just variables there, we're seeing an example of a literal equation. Another equals like distance equals rate times time. We know that all three of these values represent something. So like distance, rate, and time, because we know all of those things, this is a literal equation and this is a literal equation. So we just saw some of those on the previous page, and in some word problems might also see these coming up as well. All right, so we'll do the first word problem together and then we'll go from there. So a friend tells you, and sorry, I got kicked out of that. So we're looking at the purchase price of a car. A friend tells us that they paid a total, so including everything, of $16,368. We want to know the list price. So the other additional things, we also have to pay tax. So that $16,368 includes tax. So our total price for this vehicle is $16,368. We know that our tax rate is 0.066%. So 6.6% as a decimal, we write that, move the decimal over twice, 0.066%. So we know our purchase price, we'll represent that with X. So we have to pay for the car, and we have to pay the additional 6.6% in tax. So the 1 represents the full value of the car, the 0.066 represents the tax, and this is how we'd be able to solve this one. So we actually are going to go through and do the work for this. So we'll do it off to the side. We want to divide both of these things by 1.066. And that's how we're going to go through and do this. So obviously some big decimals here. I'd say don't do this by hand. Get a calculator out, save yourself some time. And we're going to see the purchase price of the car initially. Rounding gets us to $15,354.60. So quite a bit of taxes there. Does bring that purchase price up by basically $1,000. But we're seeing again that initial list price of the car. So the dealer advertises to you is that $15,000 number. Before you leave though with the car, you have to actually pay them that $16,000 number. So again, an idea of interpreting an equation here, writing out a literal term. So that's our purchase price. And we're going to do the same thing for the following equations down here. So some word problems applying what we just did to the real world. So any questions, as always, let me know. I will see you all in class very soon. Thanks for tuning in.